Hi guys, this is the video for chapter 10, lesson 2. So we're going to continue to look at circles here. In our last lesson, we took a look at identifying the parts of the circle and using the diameter to find circumference. So today we're going to continue to look at identifying more parts of a circle. So I would definitely take some notes over this stuff. But basically, we're going to take a look at angles that are within a circle, okay? So if I were to ask you, how many degrees is a full circle, what would you say? Well, hopefully you would say 360 degrees, right? Because a full circle is 360 degrees. Half a circle is 180 degrees. So if we have an angle that comes out from the center, so we'll name this A, B, C. These are points right here on this edge. This is called a central angle. So a central angle, and I'm actually going to type this because it's much easier. It is an angle where the vertex is in the center of the circle. An angle where the vertex is in the center of the circle. So pretty straightforward with this picture and also the name of the angle, right? Central angle coming out from the center. And so central angles are made out of radii, right? We can see that AB and CB are radii. Okay. So if we were to kind of find the sum of certain central angles, let's say I don't know, this isn't a great drawing. Let's say I draw a new one here. So let's say I have a triangle cut, or not a triangle, a circle cut up. And I name these angles, angle 1, angle 2, and angle 3. Well, I know that the sum of the measures of the interior angles, where they are all coming out from a common point from the center, we know all of these angles add up to be 360. So we could say angle 1 plus angle 2 plus angle 3 equals 360 degrees. So if I only gave you 2 of them, you could work your way through and find the third angle, right? So let's take a look at our study guide. And we're just going to take a look at numbers 1 and 2 here. If we know that number 1, all these angles are given to us, and we're missing x, angle x, well, we know the sum of all these angles have to be 360 anyway, so we could just do 360 minus all of these angles. So you could subtract consecutively 115 minus 105 minus 60. Or you could subtract the total of these all added together. So either way is fine. If you want to just plug in your calculator and subtract all of them, you can do that. So I'm going to plug that in. And I'm left with 80 degrees. So x equals 80 degrees. Okay, let's look at number 2. Well, we only have one exact measure given to us. The other one is a symbol drawn. Well, we know that anytime we see this symbol, that means it's 90 degrees. So really it's just 360 minus 120 minus 90. Okay. And I'm left with 150 degrees. Good. Okay, let's take some more notes. So go back to your note page, and what I would like for you to do is divide your page into 3 columns, because we're going to look at 3 types of arcs of a circle. So we're going to draw a picture and describe it. And the first one we're going to look at is called a minor arc. And then the second one is called a major arc. And then the third one is called a semicircle. Semicircle. So let's talk about what this is. Well, an arc of a circle is really the degree of, let's draw this here first. Okay, so there's my center or something like that. So we're going to say this is my center, circle B, and this is a C. Okay, so the arc is basically the degree of the outside of the circle. So kind of like this outer edge here. If we kind of highlighted this, it's from A to C. This is the arc of a circle, okay? So we would name this arc AC, and the way we name it is by putting a little arc symbol above it. And the arc is exactly the same degree measure as the central angle. So the central angle is exactly the same measurement as the arc. This central angle is what arc AC measures, okay? And we can also name this angle ABC. So all of these things are the same. Arc AC is equivalent to central angle X, which is equivalent to the measure of the angle ABC. And this is called a minor arc because it's less than 180 degrees, less than 180 degrees. Okay, so what do you think a major arc is going to be? Well, opposite of minor is major, which is greater than 180 degrees, right? So if here's my center, and I go like this, this is my center. I'm going to name that center C. And this is A, and this is B. And I'm just going to put a little dot right there, okay? And we'll talk about that. Well, the major arc is not ACB, right? Because that's small. That's less than 180 degrees. The major arc is going from A to D to B. So that is the major arc right there. That's greater than 180 degrees. Now, when we name a major arc, we want to use a point that is between the A and B here. You wanna have a point, an extra point to identify this major arc, because if I name this as arc AB and I say, oh, it's AB, like going this direction, well, that's the same name as if I named this arc, right? And so to clarify, we're going to name this arc ADB so that we know it's going past D and then getting to B. And so arc ADB is really the same thing as if I wanted to find the measurement. It is 360 degrees minus arc AB. So if I found AB, then I could subtract 360 minus AB to find this difference, right? And the angle that I would call it, I don't know if I would necessarily call it, I don't think I would call it ACB, because ACB describes this angle right here. And so there's not really a good like angle name for it, but really this is that degree. That's the degree that we're looking at. And a major arc is greater than 180 degrees. Okay, semicircle. Do you say semicircle or semicircle? Guess both are correct, right? Well, a semicircle is really just exactly half of a circle, right? So it is exactly 180 degrees. No more, no less. And if I named this a CB, and here's point D. So I'm going to name this arc ADB, and it's exactly 180 degrees. No question asked. So a semicircle is created by having a diameter go through and splitting that circle into two parts, right? So let's take a look at your study guide now. On here, we're going to basically decide what kind of arc it is and then find the measurement. So number 3, BA. Well, what's nice is it's labeled for us. So this angle is basically 44 degrees. Number 4, BC. All right, we need to find this measurement. Well, if I compare, here's a diameter cutting my circle into half. Well, what's half of a circle? 180 degrees, right? So to find BC, I could just do 180 minus 44. And when I subtract that, I get my measurement. What's left of it? And that's 136. Number 5, CD. Well, what are these angles here? What do we call these? These are vertical angles. So they're across from each other, created by two intersecting lines. And so CD would also be 44 degrees. See, like our angles aren't going away, they're coming back. ACD, all right, ACB, sorry, ACB. So that is talking about, let me erase some of this stuff here. That is talking about going from A to C to B, going all the way around everything here except for this little slice. So to find that, I think I would just do what, 360 divided by 44, or sorry, not divided by, subtract 44, and that would be what's left, because it's basically everything except for this angle here. So it's 316 degrees. And then BCD, ooh, that's just right here. Let me take some of this stuff off. Ooh. I don't know what I'm doing. Okay, BCD is right here. That's a semicircle. That's half of a circle. This is just exactly half here. So that's 180 degrees. I don't even have to calculate it. And then AD is right here. Okay, so if I had found BC, that's opposite of AD. And so I think BC and AD would be exactly the same. So that's 136. Okay, I forgot to name these angles. So let's name them. So this is a minor arc. And I'm going to do this minor arc just to cheat a little bit. Minor arc. This is a semicircle. This one is also a minor arc. It's less than 180 degrees. And then this one is major arc. And this is a minor arc. So there's really only one major arc. Okay, and that's it. So let's take a look at this next part, and we're gonna write some more notes. Okay, so now we're talking about if we wanted to actually find the arc length of a circle. So arc length is basically the distance of the arc angle. And so arc angle is described by the actual like degrees. And arc length is related to the perimeter of a circle, basically. It's like part of the perimeter. So if this is A, B, C, arc length is basically a distance. So I would say the distance of BC, of arc BC, and we would want to calculate, okay, what's the distance here of arc BC? And that's a length that we would measure out, okay, not an angle. So if we know the central angle, we can actually find the arc length. And this is where we get to use proportions to kind of describe what we need to find. So if I described this angle, and I know my measurement's not accurate, but let's say that this is 75 degrees. And my radius here is 10 inches, okay? Basically, the way that our arc length works is we can set up our proportion where the central angle over 360 is proportionate to the arc length over the circumference. And circumference, well, can be described as d times pi, right? Or 2 pi r. And remember, this just rolls off our tongue, but 2r really comes from where d, right? D is the same thing as 2r, 2 times the radius. So these are proportions. Basically, it's like the part of my angle compared to the total angle of my circle is proportionate to the part of my length of my circumference, just one part of my circumference, over the total of my circumference. So with finding the arc length, if I know my central angle and I know how to find the circumference, I can find the distance of my arc length. So using this example, the central angle given to us is 75 degrees out of 360 is the total. And then I don't know the arc length, so I'm going to give it a variable. And their circumference is 2 pi r. So 2 times pi times the radius, which is 10. So 2 pi times 10. And then I can work this out and cross multiply, which is really nice. So what I have here is 360 times x equals 75 times 2 pi times 10. So let's plug that in. And when I plug this in, 75 times 2 times pi times 10 this is 62.8. So when I multiply this out, it is 75 times 62.8, 36 times x. And what I'm going to do is I'm going to divide by 360 on both sides to get x by itself, and now x is 13.1 inches. Because my radius was measured in inches, so I'm going to keep this in inches. So my arc length is 13.1 inches out of the entire circumference of the circle. All right. So hopefully you took those notes and put that down. If not, rewind and copy those notes down. But basically what we're going to look at here is how to find the arc length. So I'm going to put the ratio here, arc angle over 360 is equivalent to the arc length over 2 pi r, because 2 pi r is the circumference, okay? So we're gonna find the length of all these arcs here, round to nearest hundredth. So DE, that's this, DE. We're looking for the distance of DE, basically from D to E. What would that be? So the angle of DOE right here, this angle here is 120. So basically 120 over 360 equals x over 2 times pi times the radius, which is 2. And then I can cross multiply and solve. So 2 times pi times 2 times 120. And then if you want to just keep that in your calculator where you multiply across and you keep this in your calculator, and then your final step is to divide by 360, you can do that. And then my answer is 4.19, rounding to the nearest tenth or hundredth, and in meters as my answer, 4.19 meters. Okay, number 2, DEA. DEA, that's all the way across here. So I need to find, first I need to find my arc angle first. And so if this is 120 and this is a right angle, 120 plus 120 plus 90 is 210, I believe, right? 210. So my arc angle is 210 over 360 is equivalent to, is proportionate to x over 2 times pi times 7. So I'm going to plug this in, times 2 times, okay, and then I'm going to divide that by 360, and it ends up being 25.66 inches as my units. Did I do that right? Oh, I didn't do that right. Okay, let's talk about this. This is the diameter. So I actually multiplied 2 times pi times the diameter, which really is not accurate. So really this bottom part, I should write it as just, honestly, I could just write it as pi times the diameter, right? Pi times the diameter. So when I actually work this out, this is going to be not quite as big as I thought. It would be 12.83 inches, okay? Okay, so be careful if they're giving you diameter, you know, you gotta make sure you're using the right part to find the circumference, right? Because if it's the radius, it would be 2 pi r. If it's the diameter, you just have to do diameter times pi, like we did last time. So BC, we're looking for this arc, and it says that the length of BE is 24, which means I only want the radius, which is 12. I guess I could calculate that mentally. And so this would be 45 over 360 equals x over 2 times pi times 12. Or honestly, you could just write it as 2 times 24, right? Or pi times 24. And so you can cross multiply. You can pause and work it out. And that ends up being 9.42 feet. Okay. Final one, CBA, looking for CBA, so this whole part. So that means we need to make sure we have the right arc angle, and this whole arc angle would be 90 plus 45. So 90 plus 45 is 135 as the angle. And then it's x over 2 pi r. DO is the radius, that's 3, so 2 times pi times 3. And so cross multiply and then divide, multiply this and then divide by 360. And the answer is 7.07 millimeters. All right, so hopefully you got those. And if you, when you get to do this and you feel comfortable with it, you can also rewrite this equation, which the book actually describes it this way, as x over 360, arc angle over 360. So let's clarify that. The arc angle over 360 times 2 pi r equals the arc length. So I'm gonna draw a little arc and then length, arc length. Okay. These last few, honestly, it's same thing. Find the length of each arc round to the nearest hundredth. So you can pause and work these out. Just double check to make sure if they've given you a radius or if they've given you a diameter, because that will change things, okay? So show your work, do them, and I will write the answers up here. And I didn't do number 8, so don't worry about that, okay? And there you go.